This is another recording that someone asked me a question last year, and I made a slide about it right after that. All right, I have one key and one lock. Can you unlock that door with that key? With the correct key, that is. This is the correct key for that door. So how hard would it be to do? Pretty simple to do. Now I got two keys. One of those is the correct key. One of them is not. How hard is it to open that door? Still pretty simple, but I have to try two keys. Okay? Now I got three keys. So what do you think? Impossible. Only for Obama. It's getting tougher.
Never be done.
It's getting tougher, but you can still see it's not going to take that long. So if I'm using a 1-bit key, it's done. Even 3 bits. Okay, how about this? How about 4 keys? It's getting tougher, but still doable. 5. So the question is, at what point does it get too hard to do?
So that's the step before that.
Okay, the step before that. So, when we're talking number of keys, is it important to have a large number of keys? Okay, so we think 50. You think that's pretty good? How long, if I have 50 keys, do you think it would take me to open that door? Realistically.
A minute.
Yeah, maybe a minute. Depends really the chances of me picking the right key and keeping track of which one's already tried. I always like to see people with a big old key ready to try one. Crap. And they end up trying the same key over and over. It's like, dude. Okay. Let's talk about binary real quick. This is binary. Hopefully you've all seen this. You can probably recognize it if you saw it on the side of the street. Okay? 1 through 10. Everybody with me? Hopefully. It's, binary is actually so much easier than decimal. We're just not used to doing it. So in decimal, we have to remember 0 through 9. Then what happens when we get to 9? It changes to a 0, and the next one gets incremented by 1. So 99, they're both at their maximum number. They both change to a 0. We increment the next one for 100. Binary, we got 2 numbers to worry about. We go to a 1. Up, I'm at the maximum number. Change it to a 0, increment the next number. Just like in decimal. Now they're both of them are 1s. Change them both to 0, increment the next number. Just like in decimal. But instead of having to worry about 10 toes, you worry about 2. That's all it is. Pretty simple stuff. Okay? So, 2 to the 1 is 2, believe it or not. Just in case you didn't realize that. 2 to 1 is 2. The possibilities of 2 to the 1, first, is 1 or 0. 2 choices. Okay? So if I was working with keys, I got 2 keys. One or the other. Okay? 2 to the 2 is 4. So now I have 4 possibilities. I'm just proving it to you that there's 4 possibilities of 2 squared. 2 to the 3rd power is 8 possibilities, and there's all the ones you can possibly get. So I'm just showing you the examples of what you can get. Okay? 2 to the 4th power has 16 possibilities. So 2 to the 4th, 16 possible keys here. Okay? So at what point do we have enough keys to protect our data? Is 8 keys enough? If I'm going to encrypt something, is 8 keys enough? Is 25 keys enough? How about 40 keys? That's 40-bit encryption. Is that enough? How about 56? Is that enough? I mean, that's 56-bit encryption. That's a lot of encryption. What we should be asking is, what the heck are we protecting? If I'm protecting, the Domino's pizza order, who cares? If I'm protecting, the healthcare marketplace, which sucks, maybe we need something better. I think they're actually using probably about there. It works or it doesn't. Oh, it doesn't work. It sucks. Okay, let's continue. How about up to 128 keys? Is that enough? Okay. So when you have a choice of picking encryption, you have a choice of 128-bit. That's a lot of different keys. And so basically, that's not secure enough. I mean, dude, look at that. That's a lot of keys. There's 256-bit encryption. Is that enough possibilities? I mean, that is Seriously,
What that number is.
that's a lot.
Just say that number.
That's a lot. Oh,
That would be.
now I got 1024-bit encryption. So is that enough? 2048-bit encryption. Is that enough? Okay. But the whole point is this, so you could graphically see what 56-bit looks like to 2048. But again, it really goes down to what are you protecting? How much time do you have? Because obviously it's going to take longer to generate these keys than it would a short 8-bit key or a 56-bit key. But, so what do you think, 2048 enough? Would you be happy to encrypt something with that? Yeah, 1024, come on. I think my RSA key is 1024. PGP key, sorry. It's either 1024 or 20. I think 1024 is the only one you can get for free. Does anyone have a PGP key? Do you know? Do you remember what I think it's 1024 is free, isn't it?
I think it's 10.4.
I think beyond that they charge you or something.
I think mine was 512.
Ah, well, obviously.
It was Obama.
Exactly. You're a Democrat. You can't handle the bigger numbers.
Unless you're praying money.
Exactly. So the point of these two presentations is 24-bit or 2048 enough? Hell yeah. 1024, but again, it really gets down to time. How long is this thing going to have value? And, how important is it? If it's nuclear launch codes, well, possibly. But if they're only good for the next 18 seconds, the odds of you trying that many keys on that door in 18 seconds are slim. First of all, you have to truck them in, I think. That's an awful lot of stuff. All right?